All right, so for today, today's going to be our kind of practice day for acceleration problems. Yesterday we went over horizontally projected projectiles and saw that we had to use, well, at least one of the acceleration formulas. We used the same acceleration formula for every question. Right, but today you're going to be getting a mix of different problems. So the challenge here is not so much your algebra, because I'm not worried about your ability to do algebra, but more so I got to follow the process of writing down my givens, figuring out which formula I'm going to use, and then going from there. Okay, so let's have you guys try this one. This is one of those kind of questions that you have to get basically all the information from the context of the question. It only gives out, like, lays out one number for you when it's actually giving you 3. Okay, so I'll give you guys a few minutes on that one. Okay, so for this one here, we got a bolt that falls off a roof. If it falls off, it wasn't thrown off, okay, what's its initial velocity? 0. Okay, so that's the first thing we have to get from the context of the question. Okay, and since it's falling, and you know, as far as we know, roofs only exist on Earth, what did it kind of tell us? The acceleration due to gravity is 9.81. And I don't need to make that negative because it only falls. It's not moving upwards ever. Its direction doesn't change, so that's going to be unimportant. I'm going to write that it's down, but other than that, I don't need to know that part. Okay? And then that means that the displacement is also 6.0 meters, and that's down, because it says it falls that far. All right, so now that I know that, okay, I just need to find time. All right, what formula am I going to use? We did this same operation 3 times yesterday. Right.
Means the v equals vi times t plus half a squared.
Exactly. We're going to use this one, especially since vi is 0, and we can eliminate half the formula right off the bat. Okay, so we're manipulating for t, so we're going to divide both sides by half of a, and then square root to give us t. Right, so t will equal the square root of 6 divided by 1/2 times 9.81. And if I wanted to, I could make both of those negative, and it wouldn't change what this comes out to. Okay, and I forgot to turn my calculator on. We're looking at just a little over a second. Come on. Watched program never loads. See, that turned away. All right. So we got 6 divided by 0.5 times 9.81. All right, so 1.1 seconds is our length of the fall. We only have 2 significant digits. Oh, not meters per second, 1.1 seconds. Okay, incidentally, a significant digit thing. 9.81 meters per second squared, you get that off your formula sheet. Any numbers you get off your formula sheet are considered absolute. They do not affect your significant figures, okay, as they are given numbers from your data. So it's the other numbers that you get if you're using a number from your data sheet. The only number you're getting from your data sheet for the first 2 units is 9.81, so it's really not that applicable. But when we get to unit 3 and we're talking about planetary distances and masses and stuff like that, then it becomes more important, okay, because you'll use several things from there. Okay, try that one. All right, so the final velocity is what we're looking for, okay, of a rock propelled over a 0.30 meter distance by an acceleration of 22 meters per second squared, okay, for 0.72 seconds. All right, so looks like we're going to be using this formula. D equals VF times T minus 1/2 AT squared. I want to get VF by itself. First thing I would move is add the 1/2 AT squared over to the other side. Okay, that'll equal VF times T. Then I would divide both sides by T. That'll leave me with VF. Plug in my numbers, 0.3 plus 0.5 times 22 times 0.72 squared divided by 0.72, and that should give me my final velocity. 0.3 plus 0.5 times 22 times 0.72 squared divided by 0.72. Okay, 8.3 meters per second, and that would be positive, I guess, although they said final velocity, right? Yeah, so it would be positive 8.3. Okay, everybody all right with that one? Okay, try that one. So on this one, we are looking for VI. Okay, we know it enters ballistics gel and its acceleration will be negative 150 meters per second squared because it tells us it slows. Okay, it does that for 0.252 seconds, and its final velocity is 65.2 meters per second. All right, so if you've ever seen ballistics gel, it's what they use to essentially compare the ammunition from, like, essentially guns that are suspected of being used in a crime. Okay, so if someone has been shot and they've extracted the bullet from them, okay, they can shoot a bullet into ballistics gel. It has the same consistency as the human body, so it has the same effect on the bullet, and they can compare the final shape and stuff of the bullet and figure that kind of stuff out. Okay, so it's actually pretty useful stuff. All right, so we're going to be using this one. Last year's formula, A equals VF minus VI over T, because that's what we have. Looking for VI is the trickiest of the manipulations of this formula. I would multiply both sides by T, then I add VI over to the other side so that it's no longer negative. Then I subtract T times A over to the other side. So I get positive VI equals VF minus T times A. And so that will be 65.2 minus 0.252 times negative 150. So we're looking at, it went in at 103 meters per second, so it was not a very fast bullet. All right, everybody with me there? All right, are we getting the hang of this? Okay, I mean, it's really just a matter of having the right givens written down so you can pick the right formula. All right, give that one a try. Okay, let's have a look at this one. So we're looking for how far a plane flies. So we're actually looking for distance, not displacement, in so much as they say how far. Okay, it's accelerating at positive 4.52. That's important. We know it's speeding up. Okay, and it's going from an initial velocity of 123 meters per second, okay, to a final velocity of 300 meters per second. Those would both be positive numbers. Okay, so what formula am I going to use?
A squared F equals V squared I plus 2A.
Yep. Okay, that would be the best one to use. It has everything in it that I have. So solving for D, subtract VI squared. Okay, divide by 2A. That'll leave us with D. All right, so we will have 300 squared minus 123 squared, and divided by 2 times 4.52. All right, it's going to travel 8.3 times 10 to the, no, we have three significant figures. 8.28 times 10 to the 3 meters. okay? Because that's not a very high rate of acceleration for a plane, okay? And it's a big change in velocity. It's more than doubling its velocity, so it would fly at over 8 kilometers in doing that more than likely. Okay. All right, what I want you guys working on here, okay, remainder of class, is the acceleration questions on page 6 of your digital workbook, starting with question number 2, okay? Yeah, shouldn't have any trouble with any of those. They're very much like what we've been working on over the past few days here. Okay, so the answers are obviously there in bold. If any give us trouble, then we can go through them together. Just ask.